our topic would be circles. And one of the best reasons I know for studying circles is that a circle is a symbol of the endless love of God. It just never ends. Just keeps on and on and on. So here we got a way of naming a circle, and the circles are named by the center. So here's the way you'd name this circle here. You just make a circle with a little dot in the middle, and this would mean circle R. Circle R in reference to the center. That's what that means. So when you're looking at diagrams, they might say encircle R, and they might give you some information concerning it. If the center is P, it would say circle P, and so on. So a circle is named in reference to the center. And now, for me to tell you a diameter. Sarah, can you name me a diameter of this circle?
I don't know.
All right.
FC.
FC, yes, going to the center here. Let's name it properly. FC, that would be one. That's a segment. Cole, can you see another one?
HG.
Yeah, HG would be another one. So we got a couple of them shown there. You can just write that down. HG. Sarah, can you see that now? These are diameters.
Yeah.
They go to the center. Would AB be a diameter, Serena?
No.
Wouldn't be. You know what it would be called? AB?
The second.
Pretty close. Somebody said it, I heard it.
Chord.
Chord, yes, that would be a chord. So we can, where's the chord again? Right here. Chord would be segment AB. You could also, you could break off a part of this line here and make AE a chord. You'd have to make it a segment like this. All right, so you could actually say AE. All right, so that would be a chord if you broke off a part of the line here. All right, let's go back to the radii. That's the plural for radius. I wonder if, Kayla, could you name me a radius of this circle? RD. Yes, from the center to the circle, that's going to be a radius. There are others, there are many others.
There's lots.
Yeah. How about you, Matt? Can you name me another radius? R something.
RC.
RC would be another one. Can anybody see another radius?
Yes.
Amanda? RG definitely would be another one. So we have a number of them here. These are just examples I'm putting up here. So we got radii, we got chords, we got diameters.
I got it.
Secants are different. I don't know if you know that what a secant would be, but a secant. Go ahead, Sri. Let me see if we can get a secant.
E minus E.
Would it be R?
Good try.
Would it be
AE, yes. AE, a secant intersects a circle twice.
Huh?
A secant intersects a circle at 2 points, so it would be line AE. So this would be called a secant line. AE, like this. You have to make it a line with your double-headed arrow like that. That would be a secant line. This line T would not be a secant line. Who knows why?
Because it doesn't cross through twice.
It doesn't touch it twice. It touches once. Yes. Any idea what that would be? Only have one.
Tangent.
It's going to be our tangent line. So line T would be our tangent line. It touches at one point, and this one point here, point D, it's got a name. It's called the point of tangency. The point of tangency, that's where it touches once. Okay? Something I'd like you to see very, very quickly now is where a tangent, like this line T, intersects or meets a radius, we always, always, always have a right angle. Okay? Not a wrong angle. It's going to be a right angle right there where they touch. So that would we have a right angle right there. And that's going to help us in our calculation. We have a right angle. So make a note of that, please. Where a tangent and a radius intersect, we have a right angle right there. Because we're gonna need to know that. Because once we have a right angle, we're gonna have right triangles and so on. Okay. All right, I'm gonna go ahead and go to some features now of circles, common tangents. Give me a type of common tangent, yes. Why don't you just see if you can hang on a little bit so you can see some of this. Common tangents. Let me go ahead and show you these two circles. And the question is going to be how many common tangents can you draw? Let me see how many we could draw when these two circles touch like that. We could actually draw one right here. Common means they're just touching both. One.
Yes.
Can you see it? Can we draw any others? Common?
Yeah, I see the second
We
one.
could get one down here, right?
Yes.
So let's do another one right here. I wonder if we could get another common tangent.
Yes.
Where?
Down the middle.
Right down the middle, yes, we could definitely get one common to both circles right down the middle here. So we have three that we could draw here. Three common tangents. Any idea how many we could get here, Carly? How many common tangents? Yes, you're right on that one too. We can get one on the outside here, touching both. Who wants to try and draw one?
I'll draw.
Come over here,
No,
Kelly.
draw one.
I might
Do it.
lose
I
this
wanna
up.
do it. Draw one, Calvo.
Let me see if Alex could draw the second one.
You can do it, Calvo.
You don't have to touch
Oh,
me.
wow.
Okay. It's a little bit tricky, so you can have to look up here. Right?
Down the tool.
See,
Is it
look,
right?
look, you have to look. You have to look what you're doing.
Oh, whoa.
Yeah. Yeah, right there. Come down. Yeah.
Yeah, it is.
Come down. Down.
It's okay, Calvin.
Yes.
You try.
Yeah, that's right there.
Try again. Yeah, there we go.
There you
Much
go.
better.
There you go.
Oh,
Yeah,
nice.
give him a hand. Alright. So we got two
We're gonna do the next one?
common tangents. Can we get any over here?
No.
No, we don't have any. No, we have secant lines inside, but no common tangents. All right. Let me go forward and show you a little bit more. Let me see what else I got. Oh yeah, we might as well show you how to use the tangent and radius meeting together. When you see that, it's always going to be a right angle. Even over here, we have a tangent meeting with a, huh?
30, 60, 90.
Not quite, but it's Pythagorean. We could use Pythagorean. All right, so if you're going to find x, let's say you see this on your test, to find x, you say, well, I can do that because this is a right angle. Even if they didn't tell you, once you see a tangent and a radius, you see it's a right angle, and then you can use what? C squared equals?
A squared plus B squared.
A squared plus B squared. We have to be careful we properly identify our C.
I do it?
What would be our C?
Your C would be 100.
Yes, 100, that is squared. It's going to be equal to what?
96 squared,
Plus
x squared.
x squared. All right, I'll make sure you have your calculators also, class. 100 squared is easy, it's just 1 times 1, which is 1, and then 1, 2, 4 zeros, because it's 100 times 100. So it's going to be 1, 2, 3, 4 zeros.
10,000.
10,000. But 96 squared, I don't know right off the bat. So, okay, anybody has a calculator? Can work that out. 96 squared.
9,216.
Thank you. 9,216 plus x squared. I'm going to use that to work it out. Cole, what's my next step here to find x squared or to find x?
Subtract 9,216 from 10,000.
Correct. So we got 9,216. That's gone. So this would be a 4. This would be a 1 from 9 is 8. And then 2 from to do it. 7. 2 from 9 is 7. Alright, last step, Mattia. What do I do? Square root. Yeah, so x is going to be equal to the square root 784. Carly, work that out for me, please. Square root of 784.
Yeah.
What is it?
28.
28 would be, make sense. So the radius would be 28, once we know our tangent and we know this line here. Okay, now let's take a look at another one, this one right here, which is a little bit different because we got the radius here of x, we got the radius here of x, please look, and then on the outside the extension is 32 right here. Could we use Pythagorean for this, you think?
Well,
It's a right triangle.
yeah, you could.
Yeah.
Good. All right. How could we set it up? What would be our C?
32.
Oh,
Who knows? What would be the C? It's going to be this, all of this, right?
Be
yes.
What would it be, Gary?
x plus 32.
You got it. So it's 32 plus x. This is all squared. That's a C. I hope you can see that.
Yeah.
Is equal to 56 squared
That's a good one.
plus x squared. Now this is taking it back to a little bit of algebra. Maybe I should do it up here and show you. It's going to be essentially x plus 32 times x plus 32. Honestly, I'm going to remember to do that.
Foil.
Boy.
You
hate that? All right, let's do it step
Yes.
by step. X times x is what?
X2.
X squared. All right, and x times 32 is
X30. 32x.
32x. All right, let's take it in bite-sized pieces. We're done. Inside, 32 times x is
32x.
32x. And finally, 32 times 32.
Is,
Somebody with a calculator, please.
I got this.
What is it? 32 squared.
1024.
Right now.
1,000 what?
24.
24. Thank you. 24. That's going to be equal to 56 squared. Shh, pay attention.
3,136.
3,136. Kayla, pay attention. Plus x squared. I'm going to put it right here. All right. These will go together. They're like terms. So I'm going to drop it down now. It's going to be x squared plus what? 32 plus 32?
Once you add both x.
64x plus 1,024. It's going to be equal to 3,136 plus x squared. All right, let's finish this. And I'd like you to be writing now. Don't give up. I want you to run all the way to the finish line now.
You add the x's.
You know what's going to be nice to do? Since we have x squared on the left, x squared on the right, we can subtract x squared from both sides so that we don't have to deal with it. So here we go. That's gone. That's gone. So all that's left here would be a 64x plus 1,024 equals what? 3,136. We're almost home.
Subtract.
All we have to do now is subtract what?
124.
1,024 from both sides. 1,024. Here we go. That's gone. That's 2. That's 1. That's 1. That's 2. So we have 64x is 2,112. Ben, what's the next step?
And now we get divide.
Divide by 64 and we're done. Somebody do that for me, please. 33?
Yeah.
Exact?
Yeah.
33. All right.
32.
Okay. Again, you can go back and watch this if you need to, but I'd like you to have some notes on this. Let me give you maybe one more word concerning these. If we've got, let's say, a circle, any circle, let me just go general and give you a circle. Let's say if I take a circle, any circle, and we identify a point external to the circle and we draw two tangent lines from that point. Let's get a couple of tangent lines from here, from this point. Let's say one here and a second tangent line. We can only draw two from any external point. these two segments are always going to be equal, always equal. So if you see a problem like this, you can always set it up by saying 17 is equal to what? 3x squared minus 10, because these are always going to be equal. You always know they're equal. So 3x squared minus 10 equals 17 would be a setup for that. Of course, you add 10 to both sides. So you get 3x squared equals what, Mattia? Adding 10 to both sides? 27. Who knows what to do next? Got two more steps.
Divide by 3.
Divide by 3. Get x squared equals what? 9. And then do what?
Square root.
Square root both sides. X equals square root of 9, which would be 3 for that. So it's important to know that the two tangent lines from any external point, they're equal, so you can set that equal to each other and get it done. Alright? I'd like you to, I'm going to give you a worksheet for your homework. I'll identify some of these which you